These are the vehicles that are being driven 8, 10 hours, day after day after day. If there are any vehicles in a city that you'd want to replace with zero-emission vehicles, it would be these commercial vehicles.
One of the aims of Arrival is to be able to work with companies and create a bespoke vehicle specifically targeted to their needs, which is exactly what they've been doing with UPS, with whom they have jointly been developing a new delivery van. But how will this new startup company compete on price with established automotive giants who spent over a century mastering the production line and economies of scale?
I think the real opportunity with a startup, with a new company, is you don't have any of those existing assets. You can set off in a completely new direction.
The approach that Arrival has taken can in many ways be encapsulated by the words of the influential 20th century economist Ernst Friedrich Schumacher.
He wrote something along the lines of, "An intelligent fool can make things bigger and more complicated, but it takes a lot of courage to move in the opposite direction." I love this quote. It really captures our DNA, what we do here, how we develop things.
Large automobile factories can take years to build and have a price tag of over $1 billion. Arrival believe that for just $50 million, they can take over an existing warehouse and within 6 months be able to produce 10,000 vehicles a year. Able to be built all over the world in locations where the vehicles are needed, they will employ local people, pay local taxes, require less infrastructure, and be able to provide specific models suitable to that location. They call it a microfactory, which instead of housing a conventional production line, uses a collection of robotic cells.
And we have a whole array of these cells that do different operations. But the key to it is how we link them together. We link them together through mobile robotics. So literally a little wheeled robot that carries parts and vehicles from cell to cell.
I've been building robots since I was a kid, right? From toys. I was fascinated with robots. I was fascinated with the spacecraft. So all my studies over the years were focused on this: space exploration, robotics, and AI. I met Dennis after having worked on a space mission for the European Space Agency. We discussed about how to use technology to have a positive impact on people. And we liked each other, and I jumped on board. I left the space program and I joined Arrival.
Where once in the traditional automotive industry, it was tool makers who were crucial for the implementation of mass production, today a different type of engineer is at the heart of this new way of building vehicles.
More than half of our people are software engineers. We are strongly software people. What this means is that we spread intelligence in every robotic asset that we have on the shop floor. These robots sense and perceive the environment. They gather the data, they process it in real time, and they use this data to execute operations in real time. If something changes in the environment, they react. And then we have an operation control system. You may think about it as the overlord of the factory, right? The AI that runs it. And this system gathers continuously information from all the children, from all the robotic assets on the shop floor. We have done a lot of work on computer vision, and we've developed something quite unique. And our systems are capable of understanding the position of an object, classifying that object, understanding the position in 6 degrees of freedom, so in space, in any location, a sub-millimeter accuracy. These are robots that can navigate autonomously in the environment, can avoid obstacles, can detect any anomalies in the environment and can react dynamically. And also work together. These robots can connect to each other to create a larger platform that can transfer bigger and larger payloads.
But as clever and sophisticated as the system is, if the microfactory concept is going to work, it'll need the right materials to work with.
I'm going to be a bit biased here, in that I think materials are like foundational to a lot of this. If you're going to manufacture something anywhere in the world, then you can go one of two routes. You can either source in one place and transport it, or you source close to where you're making. And our strategy is very much to try and source as close as we can to the factories to support local communities, local economies, and to build relationships in those areas. So if we want to be able to build a microfactory anywhere, on a high street, in a warehouse, you have to start asking questions about the kind of materials that are going to go into the factories. They also have to be recyclable, because you need to be able to reprocess them wherever you are. You know, if a van's built in one part of the world, it should be recycled wherever it ends up. So, and that drives a certain type of materials logic.
In order to meet all these criteria, it was decided to use an aluminium chassis onto which would be put a body made from thermoplastic composites. Able to be molded into shapes when heated, thermoplastic composites differ to many other forms of composites because it's a process that can be reversed and repeated many times, making it perfect for recycling and giving the product an almost indefinite shelf life.
It's where there is a huge amount of innovation in the industry. We can process that by 3D printing, so we can make prototypes. We can turn it into injection molded components. We can process it into compression molded or extruded, or you can, make our, garments from thermoplastic materials. Like, it's just, the amount of opportunity of thermoplastics is just immense.
The company have developed their own composites, tailor-made for their requirements. Those destined for body panels arrive at the factory in the form of rolls of fabric. These are cut to size, layered, and molded into a variety of different shapes, and all done autonomously, using far less machinery and energy than a conventional automotive plant. And what's more, waste is eliminated because the properties of the material allow any offcuts to be recycled and made into other components.
Like, that's so fundamentally different from the conventional way of working. I mean, when people join the company, they often, it's quite mind-blowing. We are weaving fabrics and knitting, and there is no paint. The colour is throughout the panel, and you can recycle the whole panel at the end of its life.
Panels are also able to withstand impacts in a way that no steel equivalent ever could. All of which is of considerable appeal to commercial fleet operators.
Their vehicles are their brand that's rolling around in those communities day after day, so they always want their vehicles to look their best. They spend an enormous amount of money every year per vehicle to keep their vehicles looking so good.
This combination of versatile materials and a highly agile production process is also changing the way the company approaches its research and development.
So in regular R&D, I'm used to working on projects that are 2 to 4 years long. And here we're expected to turn around proof of concepts in a matter of weeks. If it takes longer than a month, then it gives us pause for thought. The point is to prove your idea as quickly as you can. And then that means that you can cycle through ideas much quicker. So the other core concept for us is that failure is not a bad thing. I encourage my team to fail as often as they can, because it's only when you fail that you either discard an idea and move on, or you keep learning.
This ability to utilize the AI software to transpose concepts into production has enabled the team not only to develop commercial vans, but also buses and rideshare vehicles. With a growing list of customers, Arrival has already set up 1 microfactory in the UK and 2 others in the US, with more planned for other countries in the pipeline.
in hindsight, some of the most revolutionary ideas seem obvious. And I wonder if people will talk about microfactories that way in a few years, for instance. I can't explain exactly why nobody's thought of it before, but it is clear that bringing together the right group of people on the right mission with the right set of objectives was an important part of developing this very different approach.
There are still many challenges that need to be overcome to successfully make the transition to full use of electric vehicles.